Hey, what's going on, guys? Guess who's back? This is Daniel Bishay,
Alessandro Faretta here.
and we're going to be going over chapters 8 and 9 in Why Evolution is True by our man Jerry Coyne. And we'll start off with a pretty cool quote. He said, "We are apes descended from other apes, and our closest cousin is a chimpanzee, whose ancestors diverged from our own several million years ago in Africa. These are undisputable facts." And today we're just going to kind of go over human evolution and some other great key facts as to why we're still evolving. We're going to go over all of the research and all of the things that we know. And then we'll go over why some people are doubters. So we'll see.
Alright, so let's start with chapter 8 here. What about us? That's going to be our main question. We're going to focus on that and expand on that, and we'll get it going.
So let's briefly recap. We've talked about fossils. We've talked about geography. If you haven't seen these last two videos, check us out on YouTube. They're very great videos. At least we think so. Now, let's talk about humans.
Alright, so what about us? We've discovered many links between our past and present. Through the works of evolutionists, paleoanthropologists, geneticists, molecular biologists, and many other disciplines, we're able to find where we belong in evolution.
So we're going to go over some of the mechanisms involved with evolution and how it's affected us here today.
So common descent. We're going to start off here. Common descent describes how a group of organisms share a recent common ancestor. And as we'll be talking about later, we have evidence that we have evolved from apes. And, this is a very popular belief, and it's actually commonly accepted. It is said that the last common ancestor shared by humans is the chimpanzee. We're pretty similar to them. That might sound crazy to some people, but we'll be going through some evidence as to how we know this is true. How long ago has it been since we were super related to chimpanzees is a little harder to explain because of such rapid speciation between the two groups. But it is estimated to have been anywhere from 13 million up to as recent as 4 million years ago.
So, I know we talked about the fossil record in our first video. Again, check that out. But we're going to revisit it real quick. So, the main thing about the fossil record is it's a tangible history piece that allows us to see what our early ancestors looked like, since there were really no cameras back then. And fossil records, like Lucy, one of the greatest links of early human history, has really helped us not only understand what our ancestors looked like, but gave us a general idea how long it's been since we diverged into who we are today. More on this to come later. That's just a sneak peek.
So microevolutionary forces. So our first term here we're going to go over is genetic drift. And genetic drift, as we know, plays a role in small populations. Genetic drift is essentially the random changes in the frequency of alleles in a gene pool. You might be thinking, this can't affect humans because we're a large population. But there are actually two ways we can be affected by this. In our early years, when population sizes were still small, genetic drift had a big effect on humans, with the loss or fixation of certain alleles. Today, in certain populations, there are still small-sized populations where genetic drift can have an effect on humans because breeding is controlled. This brings us to our next point, inbreeding. Inbreeding essentially shaped human evolution. Research has shown that many early humans were highly inbred. Today, certain populations still practice inbreeding, such as the Amish, where many second/third cousins are practicing inbreeding as a result of small population sizes. However, inbreeding is becoming less and less of a reality, as even the Amish are now looking outside of their communities for breeding.
So we're going to go through the last bit of the microevolutionary forces. We're going to start off with the neutral and near-neutral theory. And we'll start off with neutral theory, which basically argued that it's an explanation for how we have evolutionary changes at the molecular level, which is a direct result of genetic drift of mutant alleles. Now, this was first postulated by Moto Kimura. However, his student, Tomoko Oda, proposed a similar idea known as the nearly neutral theory, which stated that there is a relationship between population size and rate at which molecular evolution occurs, which then determines whether genetic drift or selection is actually acting. Next, we're going to be going over migration. Now, migration seems like a really obvious one because, we all come from all different walks of life, across from different continents, and, it's a big factor of human evolution. We humans come from all over the world and inhabit all corners of the earth, which allows us to adapt to our surroundings and breed and grow roots in our new lands. We also have selection/adaptation, which basically, if you think about it, humans have to really adapt to, new and ever-changing environments. We still do have to adapt. And climates, are always changing as well. And we do this through selection and adaptation. We are selecting for traits that better promote us to survive and reproduce in our current environments that may be changing. Lastly, we'll go over mutation, which is clearly a factor in human evolution. In our DNA, errors do happen, whether they're deleterious in our DNA, wrong base pairings, mutations, all those things do occur. Now, unfortunately, this is a factor of life, but it doesn't always necessarily have to be a bad thing. Deleterious alleles from mutations are bad mutations, and usually are not as apparent as we might think. However, advantageous mutations also are a possibility, and we really want to code for advantageous mutations because these help us in one way or another.
So life history evolution. Our life history can be explained by the anatomy and behavior of humans. We examine how our behaviors, lifespan, ability to reproduce, and many other functions have been shaped by natural selection. Natural selection has a big part in how we're able to explain at which age we reproduce, our reproductive success, and offspring, as well as our general human behavior. Most of our evolution can be traced to our early humans, hominins, which had to learn how to live their life and reproduce without the luxuries of life we have today. Many of our instincts come from our hunter-gatherer ancestors, which is why our bodies are so efficient at producing life and living life, all based on natural selection, essentially the lessons we have learned to make us optimal humans as we are today.
So I'm going to quickly go over the evolution of interactions. We humans are very much interactive. Now, we're a species of cooperation. We come together for the advancement of the common good. Now, this idea of cooperation can be linked to our ancestors who, as early humans, really needed to cooperate with one another to ensure their survival, and studies have shown that those who worked together survived and did much better than those who were selfish and worked alone. This brings up a good point of altruism, which is essentially sacrificing yourself to ensuring the survival of your kin. But why is this important, you might ask? Well, because if your kin survives through a selfless act of your own, their genes are very similar to yours, essentially promoting success and ensuring your genes will live on.
Evolutionary development, also known as Evo-Devo. Evolutionary development is the comparison of development through our evolution. This has been a major factor in human evolution as we develop in a very fascinating way. 9 months in the womb, and out pops a human. A human that needs to be taken care of through its adolescent years. But the great thing is, our development allows us to be able to produce other humans and take care of them. It's a constant cycle of development. Now, sometimes things go wrong and human development is halted, or there are birth defects, and those can affect certain life processes that would otherwise be able to take place. This brings us back to mutation. The great thing is, though, we can use our genome to see our past and see how far we've come.
Now, let's take a look at macroevolution, which essentially is the big picture. We've talked about all the microevolutionary processes, but what about the macroevolution view? Now, macroevolution essentially looks at humans on a large scale. We examine things such as how we're related to other species of humans and how we've evolved. We'll provide a few examples coming up.
Let's start with some background. It was impossible to assume that we could find a missing link between humans and other apes, as we've already established that there is an evolutionary relationship between us and apes. But it's fair to assume that we can find our evolutionary cousins. We'll be going through some examples of our ancestors in a second. But first, It's important to note that the best transitional form we've identified between human and ancient apes is...
That's right. If you guessed Lucy, you are correct. Lucy is a combination of several hundred pieces of bones that represents the species Australopithecus. It represented a walking bipedal upright skeleton similar to humans that supported human evolution. Now Lucy, if you're interested, was named after paleoanthropologists who discovered her while listening to the Beatles song Lucy in the Sky with Diamonds while discovering her.
Homo habilis. Alright, so more on him. His name meant handyman. It was the first tool-using human. Although they're the least similar to modern humans of all species in the genus Homo, they are an important part of human evolution.
Homo erectus. Now, Homo erectus meant upright human. It seems to have originated inward from 1.9 million years ago up till recently 70,000 years ago. Now, they have seemed to originate from Africa, although there could have been migration through Eurasia.
Genetic changes, again. We have changes not only in our anatomy and physiology, but also in our behavior, language, brain size, and how we're configured. Even though we closely resemble our cousins, the apes, we had to evolve into humans. To evolve into what we are today likely requires substantial changes in our genes in comparison to apes.
Now, let's just summarize it simply. Everything we've learned from our human fossil record, combined with everything we know about genetics, microevolutionary forces, history, macroevolution, our past, all the discoveries we've identified, we know one thing. We are evolved mammals that have transformed over many, many years. We are still transforming, evolving. So we presented the evidence. Now let's look at why people still aren't believing. So we're going to quickly go over why people don't believe the evidence that has been presented with wrapping it up with Chapter 9. We have evidence in the forms of fossil records, vestigial traits and structures, biogeography, embryology. We've seen major evolutionary changes, not just on a small scale. We've even seen changes in our fossil record, and we see it every day in our lives. We've even found transitional forms between ocean life and land life. So why is there still so much doubt in those who don't believe in evolution?
Darwin was right. From the fossils we find to the genes we sequence, we've been able to support that species evolved from common ancestors. We haven't proven evolution to be untrue. By saying evolution is true, what we're really saying is we are able to verify the major concepts of Darwinism. But the controversy is good. It allows us to test alternate ideas, make different observations, and perform experiments. And another quote here, a science without controversy is a science without progress.
In essence, those who choose not to believe in evolution generally believe in two ideas. The first being naturalism, which is the view that only the way to understand the universe is through the scientific method. The second being materialism, which is the only reality of our world is the physical matter of the universe, and that everything that else comes from physical laws acting on that matter, giving little to no importance to spiritual or emotional matters. However, these ideas are completely unrelated when it comes to evolution and how evolution affects us.
What is evolution? Evolution is simply a theory about diversification of life. We aren't trying to explain the meaning of life or tell people how to live their life. It's not about a sense of behaving or reason for our existence. It's about explaining how we got here, not why we're here. Those who don't believe in evolution are afraid of evolution because they believe evolution is trying to explain our existence, when in fact, all it is trying to do is explain how we got to be where we are today.
Evolution really is a wonderful thing. It's not about morality. It is what it is. Take it or leave it. Here's another great quote. I have tried to show that two things we can make of it are that it's simple and it's marvelous. That's talking about evolution. Evolution is simply a fact of life. It isn't something we need to concern ourselves with our ideals, morals, or religious beliefs. It's okay to have your own beliefs as to how you came to be. Evolution is science. As we've grown to accept that gravity for what it is, we need to accept evolution for what it is.
Final thoughts. With the evidence we've gone over and through the research we've done, we definitely believe that humans are still evolving. It's difficult to ignore evolution when all the energy and resources of researching evolution have helped explain how we got to where we are today. It's okay to have our own beliefs. Many find comfort in religion or other aspects of their daily life that they believe to bring them spirituality. Evolution is okay with you being spiritual. In fact, it doesn't even care. Evolution is here to explain a concept, and that's it. There are no alternative motives.
We're going to leave you with one final quote from our man Jerry Coyne. We are the one creature to whom natural selection has bequeathed a brain complex enough to comprehend the laws that govern the universe. And we should be proud that we are the only species that has figured out how we came to be. And here are the sources we used for this presentation. In addition, we also used our textbook by Fatuma. So, we want to thank you guys again for watching our videos. We hope you enjoyed not only this final video, but our previous 2 videos. If you haven't seen them, please check them out on YouTube. And thank you guys again for taking the time to listen to us. And there we are, the 3 amigos.